For this lesson, we are going to be learning how to multiply monomials. All right, you may have heard the term before, you may have not. If you haven't, that's okay. We're going to cover all of that stuff as we get started. So, without delay, let us actually get started. All right, we're going to get going with our essential question. Actually, let me zoom in a bit. Actually, I'll zoom in after I do this essential question. So since we're learning how to multiply monomials, that's going to be the focus of our essential question for this thing. So it's going to be, how can I apply the laws of exponents to perform operations on expressions? And that sounds a little bit intimidating, but we'll break it down so it's not so bad. Let me type that better. How can I apply the laws of exponents to perform operations on expressions? All right. Ooh, I got a little bit of typo there. Perform, not perform. That's not a word. All right. So how can we apply the laws of exponents to perform operations on expressions? That's our essential question. So by the end of this lesson, you will know how to do that, at the very least with monomials to a degree. We'll cover more of this stuff as we get moving forward. All right. But let me zoom in because I'm probably going to be typing out a good bit of this. All right. So, excuse me. The first thing we need to do is define a few things and understand how some of this stuff works. A monomial, that's what we're going to be covering most of this lesson with. A monomial is a number, a number, a variable, or the product of a number or one or more variables with non-negative integer exponents. Okay, with non-negative integer exponents. So this could be a number like 2, or a variable like x or y, and or the product. So it could be 2xy, something like that. All right. And then with a non-negative, and that literally just means positive or 0. All right, non-negative. That's not something that should be too super duper intimidating, but it is a word we don't see often. Non-negative means not negative. Okay. It has only one term. Only one term. Actually, let's spell it out so we don't get confused with our words and numbers. One term. And then we also have to remember that a constant is a monomial. So if we just have a number, like good old number 2 here that we used up here, if we just have that, that is a monomial. All right, so we're going to look at how these monomials look when we use them with powers. So it says, explore multiplying monomials with the same base by completing the table below. Now, will it be quicker to write or type? I'm going to write them out. All right, so it has 2 cubed times 2 to the 5th. So that's the same as saying 2 cubed. Let's use this color here. My 2 cubed I'll write in this pink. 2 times 2 times 2. That's how we write 2 cubed. And then we're going to multiply it by 2 to the 5th. 2 times 2 times 2 times 2. 1, 2, 3, 4 times 2. That looks kind of weird, doesn't it? We are literally just saying 2 times 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 2. And the way we write this out, anytime we have the same thing being multiplied by itself, that's where we get powers from, exponents. That's how we have this 2 cubed. That's literally 2 multiplied by itself 3 times. And this 2 to the 5th is 2 multiplied to itself 5 times. So in this case, we've got 2 multiplied to itself 8 times. So that would be 2 to the 8th. That's how we write that as an exponent. And then if we look at this next one, 4 to the 5th times 4 squared, we have 4 times 4 times 4 times 4 times 4, all multiply. And the only reason I'm using this multiplication symbol is to separate the two. They all mean multiplication. And then 4 squared is going to be 4 times 4. Like I just said previously, if we go through and we look at how many times is 4 being multiplied and then just draw that as a power, we get the same thing. 1, 2, 3, 4, 5, 6, 7. So that's going to be 4 to the 7th. And let's do 3 now. We have 3 to the 1, which could just be written as 3, times 3 to the 6. 3 times 3 times 3 times 3 times 3 times 3. All right, so that's going to be 1, 2, 3, 4, 5, 6, 7. As an exponent form, that'll be 3 to the 7th. All right, and then we have a variable. The same rule applies for the variable. We have x to the 4th, so that'll be x times 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 x. 1, 2, 3, 4, 5 times x times x. If we count all these together, we end up with x to the 11th. Okay, so if we look at these columns, this middle column here, we're under expanded form, and then this exponential column here, or exponent form here, we see that when we look at these portions here, each of these exponents, we've just kind of, wrong one. We've just added them together. We've added the pink and the purple for each of these lines together. So with this first one, we have this 2 cubed times this 2 to the 5th. When we write it out in exponent form, that becomes 2 to the 8th. What did we end up doing? We ended up just adding these things together. These two different exponents. Same thing with this 4 to the 5th and this 4 squared. We ended up just adding these exponents, all right? And if you go through and you look at these, that is one of the things that's happening. All right, to go from, let's go ahead and type this out just so we have some words for it. To go from expanded form, or to go from the first column through our expanded form to the exponent form. So from the first column to the last column, we added the exponents. And I kind of mentioned that a little bit in passing with the last unit. The basis of this has to deal with literally adding these exponents. That's the important part for this. So when we multiply the same base, and when I say base, I mean whatever is underneath that exponent, when we multiply the same base, we're going to add exponents, all right? So that's going to be kind of a rule, so to speak, for this, but that's going to be the easiest way to remember. When multiplying the basis like bases or the similar bases, we add exponents. All right, so a general way to write that, so we don't use specific numbers and things, is to write it like this. If we have, I'm going to need 3 A's. I need an A here times an A here is equal to an A here. All right, so if we have an A raised to some power that we don't, let's just say M, we don't know what this power actually is. We'll use a variable for it. So our variable A raised to some unknown number, M, times our same variable A raised to another unknown number, N. What we're going to get as a result will be A is equal to the power of M plus the power of N. Okay, that's what our new power is, M plus N. And that's the same thing we've just done. So if we look at this X here, if we look at this X raised to the power of the 4 times the X raised to the power of the 7, 4 times X to the 7, we end up with our X is equal to 4 plus 7, which happens to be 11, okay? So this may seem a little confusing, but we see it in action. So if I had this like this, let's look at this x to use this to define the rest of this rule. We have this x is going to be raised to the power of 4 plus 7, right? That's the same thing as writing x to the 11, because we can actually add 4 and 7. Okay, so using that stuff there, we're going to look at another example. I'm going to do one, and then I'm going to leave the one that's a little bit more difficult for you all to test your abilities. All right. So when we have this one, using how we just did it, we have this 8. We could do it a couple of different ways. We could do it using the rule, the power rule that we just learned, or by expanding these things out. Once you get comfortable using the power rule, you'll like using that because it's quicker. But for the sake of this demonstration, I am actually going to write them out. So we have 8. Let me use a different color. Let's put our numbers in red. 8 x to the 5th will be 8 times x times x times x times x times x. 1, 2, 3, 4, 5. And when you're writing variables that are multiplied, you don't have to put the dot next to it. We do that just to make things easier. To save time, I'm going to stop doing that now. Times my 3. I want that one in red. Times my 3, and my x squared is going to be x times x. What we end up doing is multiplying these numbers, the 8 and the 3, and we end up with a 24. And then x to the 5th times x squared. We add these x's together. 1, 2, 3, 4, 5, 6, 7. That'll be x to the 7th. All right. And we write it all as once. So this is how we do it when we're expanding it. If you wanted to do it just using the rule we just learned, you multiply the numbers together first. You multiply these things together, and then you add the exponents. So 8 times 3 would give you 24. And then x to the 5th plus x squared will give you, or the 5th, the 5 plus that 2, you still keep that x, it gives you 7. You get the same thing either way you do it, all right? So with that in mind, go ahead and try number 2. That one can be a wee bit difficult or confusing to look at, but I think you can do it. All right, next we're going to look at what happens when we have a power raised to a power. So if we have something like this example here, 2 cubed to the 4th. All right, so this says explore raising a monomial with an exponent to another exponent by completing the table below. And I'm not going to go through and complete all of these. I want you to try a couple on your own. I'll do 2 of them, and I want you to try the other ones. So this first one, we have 2 cubed raised to the 4th. All right, so 2 cubed, that's our first little piece right there. That'll be this 2 times 2 times 2, but it's cubed. So that means this is our 2 cubed right here, but it's raised to the 4th. That means we need to multiply this out 4 times. Times 2 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 times times 2 times 2. 1, 2, 3, 4. Yep, I did that right. All right, this is what we end up getting with this. If we were to go through and count all these 2's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we would write that as 2 raised to the number of the times we multiply, which would be 12. 2 to the 12th. Okay? So I want you to try that with this 4 to the 5th squared. I'm going to do it, this next one with this xy, because that one may be confusing. Xy to the 5th. That's like saying xy times xy times xy times xy times, last time, xy. All right, 1, 2, 3, 4, 5. So I've got 1, 2, 3, 4, 5 x's. So that'll be x to the 5th. Then I've got 5 y's as well. So that'll be y to the 5th. Okay. So going back, I want you all to try these, the 2 I skipped and the one that's after the one I just did. As you go back to this, take a second to look at the first column and that last column. All right. If you look at it, you'll notice that when we have a power raised to an exponent like we do in this example, our result is those two things multiplied together. Okay. So to go from the first column, can't spell UMN, to the last column, we multiplied the exponents. All right. And that's the important part with this one. Let's underline that in the same purple color. So when we have an exponent raised to a power, we multiply them. But if we have an exponent, two exponents being multiplied together, we add them. It's kind of a little funky to think about, but that's how it works, okay? So to put that into words for my linguistic people, when we let's do it this way. When a variable is raised to an x, or when a variable that's already raised to an exponent is raised, I can't type today, is raised to an exponent, we multiply the two. We multiply the exponents. Let me put it in there like that. We multiply the exponents. Okay. So we're going to look at a example, and then we'll go from there. So let's look at this. This x squared cubed. This x squared cubed, this would be something like, there we go, draw tool. This is something like, this is writing x times x, because that's what x squared is, times x times x times x times x. And then how many total x's do we have? We've got 6. 1, 2, 3, 4, 5, 6. X to the 6. Or what we could do is just multiply these two together. 2 times 3, since this is an exponential term, this x squared being raised to a power. So we just multiply this 3 times the 6, and that's what we end up getting when we do it that way, x to the 6. All right, I want you all to try number 4. And we'll look at our next example. If we have more than one thing that's being raised to a power, even if those things have exponents, we have to multiply everything that's in the parentheses out. Like if we look at this number 5 here, I'm going to do this example and then we're going to explain it to you. Okay. I'm going to explain it to you in words. So when we look at 5, we have a squared b to the 5th cubed. That's the same thing as saying a times b times b times b times a times b times b times b times a times b times b times b. Okay, we have our a squared a. Oh, that's b to the 5th. I forgot 2 b's on each of these. B. Okay, now I got my b to the 5th. Careful, make sure you don't make mistakes like that, because that will really throw off your problem. Now we've got this, and I've got them all cubed, or I've got them written out 3 times. That's writing it cubed. Instead of writing it out like that, a quick way to do it would be to multiply this exponent on the outside to each of these. So 3 times 2 is a to the 6. And then 3 times 5 is b to the 5, or not 5, to the 15. And you'd get the same answer if you went through and counted all these things together and did it that way, okay? So when we are looking at the exponent, when we have two different things multiplied together, that's called a product. We raise everything in that product in the set of parentheses to that power. So let's put that into words. When a product is raised to an exponent, we raise everything, RAIS, in the parentheses to that exponent. Okay. And then doing that gives you the same thing as the example I just showed you. So I did it first, and then I put some words to it. Now I want you to look at what I did and the words I put to it to do number 6. All right. That's the end of these notes. Not a long set of notes, but it can be a little bit confusing if you're not careful with how you're doing this. Okay. Go back, do the examples I left for you. And if you run into trouble, if you get confused about something, come back to the Zoom, ask for help, and we'll get you going the right way. All right. After this, go ahead and get started on the classwork. And remember, if you need help, come back to Zoom and ask.